Hello students, how are you all? I hope you are doing absolutely fine. So welcome all of you at AriserTalent, and we are discussing about our chapter of the physics that is about the electricity, and in our previous lecture we have discussed some of the numerical problems that are related to the power and the heating effect of current. Now today we are going to discuss about very interesting topic that is about the AC and DC. Now what is AC and DC? AC and DC are actually our alternating current and direct current. Now, you have generally heard about the voltage or the current that we are using in our homes is 220 volt 50 hertz AC. Now, what actually is AC and what actually is DC? This is a very important terms in the physics regarding your chapter, that is electricity. Now, what is direct current? So, firstly we are discussing about the direct current. Direct current is actually a current whose value does not change with respect to time. It means the current which does not change with time is known as the direct current, and the current which is going to change after each and every cycle is known as the alternating current. As the name indicates, alternating, it means its cycle will repeat itself after a fixed period of time. So, direct current is a current does not change with respect to time. And alternating current is a current Alternating current is a current whose value changes with time. So now, if I am going to plot a curve for direct current or the alternating current, so what I can get here, for the direct current, I will get a curve. If we are plotting a curve for the direct current, and the curve will be between the current and voltage, and it came out to be the straight line. It means you are getting a constant value for the different values of the current and voltage here. So this is the curve for direct current. Secondly, if we are going to plot a curve between the alternating current having the different values of voltage and current, you will get a curve which is going to repeat itself after a regular interval of time. So, if we are plotting a curve between V and I, suppose we are assuming here the value of V and here it is a value of I. This is actually a VI curve we have, or we can say it is a current with respect to time, so you can plot it like time here. It means for the different value of time we have a different values of current here. And this will be the curve for our alternating current. So, how will be the alternating current showing its variation with respect to time? What actually happens here, you will get a curve like this. It means after each and every cycle, the current is going to show the different variations here, and the number of cycles covered in 1 second is termed as a frequency. So, many times we have heard in our homes that we are using our AC current at a frequency of 50 hertz. So, what is this 50 hertz? 50 hertz is a number of cycles covered in a 1 second. So, if I am taking this cycle, So this entire period will be the frequency of that particular part. So this is the variation of the alternating current we have seen here, and you can easily see from this graph that alternating current is going to change its value after a regular interval of time, whereas the DC current is showing the single variation. It means we are obtaining a constant line for that particular part. Now, this is the main difference we have heard. We have seen that AC current is changing with time and the DC current is remaining constant over the entire period of time. Now, what are the next major difference between the AC and DC current? If I am talking about the DC current, it is not much hazardous. If you are using the DC current, you will not get much electrical shock or anything else. But AC current is having a very high frequency, so it is handled very carefully, because if it is not handled carefully, it will lead to the electric shock. So it is not easy to use, it needs a lot of maintenance, and DC current is simply easy to use. Now, if you have seen in your physics lab, if we are going to connect any of the instruments, suppose we are drawing any circuit or we are designing any circuit, just we are connecting the ammeter and voltmeter in series and parallel according to the requirement of that circuit. Now, what actually happens there when you connect the ammeter in series, because ammeter is always connected in series, so what you will observe there, when you connect the ammeter in series, DC current will flow through it and it will not cause any hazard. But this AC current is not simply measured by using the ammeter. It can be used by only the specific devices or the high frequency devices designed for measuring the AC current. So, the one more difference I can found here, one more difference we are find here is regarding the device. And what is the device? Simply, if I am going to measure the DC current, if we are going to measure DC, we will require ammeter. And if we are going to measure the AC current, what we will require? We will require a specific devices. So this is the next point regarding their devices. One difference is their definition, another difference we have seen regarding their curve, which is showing the variations with time, and the third difference is categorized on the basis of devices. Now, what is the fourth difference between the AC and DC current? That is, AC current will not be easy to handle and the DC current is easy to handle. Now, what will be the fifth difference regarding AC and DC current? It will be, now the next difference between AC and DC will be that DC current can be simply produced by the cell or battery, but for producing the AC current, you will require a lot of chemical reactions. It may be the thermal reactions, it may be the nuclear reactions, or many more reactions. So, it is simply produced by battery or cell, or it may require a large amount of chemical reactions and more amount of apparatus. So, the next term will be source of production. So, the source of production for DC will be cell or battery, but for the AC we have thermal reactions and nuclear reactions are required. So, this is about the source of production we have. Now, the last difference between AC and DC is that DC current is a base of electronics and AC current is a base of electricity. So, the last will be AC current is a base of electricity and DC current will be the base of electronics. if we are talking about electronics, we will always discuss the DC current, but if we are going to the electricity or the electrical branch, we will always discuss the alternating current, because alternating current is linked with our is our electricity. So these are the major differences between AC and DC we have seen here. So I hope this topic has been clear to you, that what actually the AC and DC is. Now let's move to the next topic, that we are using the term AC again and again. So what are the advantages of AC over DC and what are its disadvantages? So let's discuss about advantages of AC over DC, but before that just copy it from here. The next topic is about advantages of AC over DC. Now, do you know that 90% of electricity or the 90% of the form of the energy we are using in the world is in the form of the AC, but only 10% part is of for the DC, which is used for the further applications we have. But in India, if you are using the alternating current, it can be counted as a 1/100 of a second, and it will give you a frequency range of the 50 Hz. It means in India, if we are using the electricity, the voltage or the current rating will be 220 volt 50 Hz. All the devices at our homes or our workplaces are operating at a 220 volt 50 Hz. So this is a standardized in terms of the voltage and the frequency we have. But what are the advantages of AC over DC? So the first and the foremost advantage of AC is that this AC can be converted into DC very easily. So it becomes very easy to use AC. Second advantages of AC is that if you want to step up or step down the voltage, you can easily connect any of the apparatus or any of the instrument in parallel with that AC. So there are few advantages which make AC more valuable as compared to the DC. So let's discuss these points. So firstly, 90% part we are using of AC and remaining 10% part is used as a DC. This is for the world. So 90% of the power generated in the world is in the form of the alternating current, but only 10% of the power generated is used as a DC current. Now, in case of India, the electricity, the alternating current is changing its direction about 1/100 second of every cycle. So in India, the frequency used is 50 Hz that we have discussed earlier. Now, the first advantage of AC over DC is that AC can be simply transmitted to a distant places. It means at a places which are very far from each other, we can easily transmit AC at a long distance places. So the first advantage is about AC can be transmitted at distant places. Second advantage is that AC can be changed by changing voltages using transformer. It means if you want to change the value of the voltages, you will just simply connect the transformer in accordance with that device. You can step up or step down the AC. This is the another more advantage or important feature of the AC, that it can be easily stepped up or stepped down. So, it can be stepped up and stepped down. If you are going to buy AC generators, the AC generators are more cheap as compared to the DC generator, which is the another advantage of AC over DC. So, AC generators are cheaper than DC generators. AC generators are cheaper than DC generators. So, these are some of the advantages of AC over DC. Now, every component has its own advantages and disadvantages. So, there are two more disadvantages that we have to discuss of AC over the DC. So, what are the disadvantages of AC over DC? The first disadvantage is that the processes we are generally using, like electrolysis, electroplating, or any other refining form, this cannot be used with AC, but it can be used with DC. Second disadvantage of AC over DC is that if you are going to discuss about the AC will cause more harm as compared to DC, because this current is much hazardous as compared to the DC, because it is operating at a frequency of 50 Hz and the voltage range of 220 volt. So, the first disadvantage is electroplating, electrolysis and refining is not possible with AC. So, these processes are not possible with AC current. Second feature is AC is more hazardous than DC. It requires a lot of maintenance to carry AC current as compared to the DC current. And we have one more disadvantage here. You know that when AC current is passed, it needs a more amount of layers to pass through it. Therefore, whenever cables are made to pass AC current through it, it can be formed by the different layer of the material. But what happens in case of the DC? When the DC current is passed, it almost covers the entire surface, because it carries the surface from within. It means the current will going to pass within the surface. So, the next disadvantage is that AC will require more layers. It means more layer of insulating cables to pass through them. But DC will pass within the entire surface. So, this is the disadvantage of AC over DC. So, these are some advantages and these are some disadvantages we have. So, this is the AC and DC current. So, simply theoretical type questions maybe arises from this part. Now, we are going to discuss about the very important law of the physics, that help you to find the current in any circuit or any loop or in any mesh. So, the next law is about the Kirchoff's law. So, just copy it from here so we can start our next topic. So, our next law is about the Kirchoff's law, which is basically used to find the current in any circuit. the Kirchoff's law is a very important law in physics which is basically used to determine the direction of the current, and Kirchoff has basically given the two laws. The first law is known as the junction rule and the second rule is known as the loop or mesh rule. So, what the first rule states that the first rule is basically dependent upon the law of conservation of the charges. It means the total sum of the current at any point or at any junction in any system will be equal to 0. It means summation of I is equal to 0. It means current entering the system will be equal to current leaving the system. So, what the first law states that, let's discuss here. So, Kirchoff's basically given the two laws, Kirchoff's first law and Kirchoff's second law. So, the Kirchoff's first law is basically known as the junction rule. It is known as a junction rule. And the Kirchoff's second law is known as a loop rule or a mesh rule. So, the name of the second law is loop rule or mesh rule. So, this is about the second law we have. Now, starting the discussion with our first law, that is known as the Kirchoff's first law, which is known as the junction rule. So, now, from this diagram, you can see that we have considered a junction at a point A. Now, what you can analyze from this diagram, you can see here at the point A, the two currents are entering in the system. What are the two currents entering in the system? The two currents are I1 and I2 we have. And you can see that from this diagram that current number 3, 4 and 5 are leaving the systems. So, it means two currents are entering in the system and 3 currents are leaving the system. So, the two currents that are entering in the system will be taken as a positive sign and the system which is leaving the current is taken as a negative sign. So, the Kirchoff's first law, that is the junction rule, states that the sum of the currents at any junction will be equal to 0. So, the statement here will be sum of currents entering at any junction will be 0. So, in the form of a formula, I can write here summation of I equal to 0. Summation I equal to 0, or we can also write it as a capital I because current is denoted by the capital I. So, the summation of capital I will be equal to 0 and states that the sum of the current at a particular junction will be equal to 0. Now, you can see that at the point A, two currents are entering here. So, what are the two currents here? I1 plus I2. Which are the currents which are leaving the system? The currents which are leaving the system is 3, 4 and 5. So, I can write here I3, I4, I5 equal to 0. Why I am substituting the negative sign in front of I3, I4 and I5? Because these systems are just these currents are just leaving the systems here. So this is the basic formula we are getting from the Kirchoff's first law. Now, from this law, you can easily understand that if the current, summation of current equal to 0, it is following the law of conservation of charge. So what we can say, Kirchoff's first law is going to follow the law of conservation of charge. So we can also write here, Kirchoff's first law follows law of conservation of charge. So this is all about the Kirchoff's first law. Kirchoff's law is a very important law in physics for determining the value of current. So this topic is not only for your 10th level, but if you are going to take a science branch in your 11th, 12th, this topic is again very important. Now, let us move to the Kirchoff's second law. So before that, just copy it from here. Now, let's discuss about the Kirchoff's second law, that is known as a loop rule or a mesh rule. Now, what the second law states that? Second law basically states that if you are taking any loop or mesh, then if you are going to multiply the current with the resistances, then it will be equal to the EMF of the EMF present in that circuit. So the statement of the Kirchoff's second law is that in any closed circuit, the closed circuit is known as mesh or loop. In any closed circuit, the product of current and resistance will be equal to EMFs of that cell. So this is about the Kirchoff's second law, and mathematically this law can be written as summation E equal to 0, where E is the EMF of a battery because we are denoting the EMF with the small e, and sometimes it can be also written as a capital E. So this is the mathematical expression for the Kirchoff's second law. Now, let us consider a circuit here for the understanding of that second law. So its second law might be clear to you. So let's draw a circuit diagram here. this is the basic circuit I have considered here for the Kirchoff's second law. What you can see in this diagram, we have connected the three resistances in parallel, R1, R2 and R3, and we have uses two batteries having a electromotive force, that is EMF, that is equal to E1 and E2. Now, if you want to determine the current in this circuit, you have to establish the equations according to this rule. Now, firstly, I am considering here that the current that is flowing from here is I1. I1 current is flowing in this circuit. From this E2 battery, let's assume that the current is flowing I2. Now, if this I1 current and I2 current goes into the third resistor, it will get the sum of I1 plus I2. So, for the third resistor, what I am getting? The sum of I1 and I2. Now, if you are going in a circuit clockwise, what you will have to do? You have to take the directions of a current in a negative manner. So, let's apply the Kirchoff's rule to this diagram. So, what I am considering? I am considering it as a loop 1 and I am considering it as a loop 2. So, how many equations we will get from this diagram? We will get two equations here. So, this is our loop 1 and this is our loop 2. Now, let us set up the equations for the loop 1. If I am going from here, what we have to do? We have to keep the sum of EMFs equal to 0. So, the product of I and R will be equal to the EMF of that circuit. So, what I am doing here? I1 must be multiplied by R1. I1 must be multiplied by R1. And what we are doing here, we are coming in the direction of the current. So, if you are going in the direction of the current, you have to just take the sign opposite here. So, I am taking here the negative sign. Plus E1, that is the battery here. Now, if I am going from here, what I will get? E2 here. After E2, what is the value of the current here? The value of the current here is I2R2. So, I2R2 equal to 0. So, you can easily see from here that we have completed our loop 1. And what is the loop 1 states here? I1 R1, that is the direction of the current I am taking here. Battery E1, battery E2, and this will be I2 plus R2. So, we have completed our loop 1. Now, let's move to the loop 2 we have. In loop 2, what you can see here, there are three things here. I2, R2, E2 and this R3 resistances. So, this equation is for loop 1. This is our loop 1. Now, for the loop 2, I can write the equation minus I2, R2. Why minus I2, R2? Because again I am going to the direction of the current. Now, it will become E2 and this will be R3 multiplied by I1 plus I2. Why I1 plus I2? Because we are going in the direction of the current. So, if we are going in the direction of the current, we will have to take the negative sign for the product of I and R. So, this is the two equations we are getting here for the loop 1 and for the loop 2. On solving this equation by substituting the fixed values, we will get the value of the current here. So, we have discussed about the Kirchoff's first rule, that is known as the junction rule, and the second rule, which is known as the loop rule or the mesh rule. Why it is known as the loop rule? Because we are applying the conditions in the loop or a mesh. It means in a closed circuit we have. So, this law is very important in physics for determining the value of current. Now, let's do a numerical problem on this topic. So, this topic has been cleared to you. So, let's do a question here. So, now, this is our numerical that is completely based upon the Kirchoff's law, and what you have to do here, apply Kirchoff's voltage law to the adjoining circuit and obtain the equations for I1 and I2. So, you have to obtain the equations for I1 and I2, and the first step what you have to do, you have to just mark the direction of the current in the circuit. So, the first step we are doing, mark the direction of current in the circuit. Now, How I can mark the direction of the current in the circuit? This is our battery. Suppose I am assuming that the current I1 is flowing through it. So this current will be going like this. Now, for this circuit, similarly, we can draw the current like this. This is our current I1 and this is our current I2. So I2 will going to be flow from this part. Now, what will be the 15 ohm resistor will obtain the current? The current will be in the 15 ohm resistor will be I1 minus I2. It will be I1 minus I2. Now, apply Kirchoff's second law in the loop 1. This is our loop 1 and this is our loop 2. If I am going to apply the Kirchoff's law in the loop 1, what you have to take? You have to take the directions of the current. If you are going in the direction of the current, take it negative. But if you are going in the direction of the current, either take the values, all the values negative and just opposite the direction of the battery. But if you are taking the positive sign, take the terminal of a battery as you are going from there. This is positive terminal and this is negative terminal. So if I am going from clockwise manner, I will take the direction of a battery as a 3 volt. So, apply the Kirchoff's second law in loop 1. Now, what will happen in loop 1? Firstly, what we will do I1 into 10. That is equal to I1 R1. I1 into 10, second value of the current we have here is, this current is flowing in this branch too. So, I can take 20 into I2 and lastly, the battery of 3 volt is connected here. So, minus 3 will be equal to 0. So, this is the equation for loop 1. Now, loop 2. This is our 15. This is our loop 1 and how many resistances are coming in the loop 1? 10 ohm and 15 ohm. So, what we will do here? We will multiply I1 by 10 plus 15 I1 minus I2 minus 3 equal to 0. So, this is our equation for the loop 1. Now, let us take the loop 2. How many resistances are connected in the loop 2? You can see that we have the 3 resistances, 20 ohm, 50 ohm and 15 ohm. So, it must be equal to I2 into 20 plus 50 into I2 and minus 15 multiplied by I1 minus I2. Now, why I am taking the minus 15 here? I am taking minus 15 here because we are going in the direction opposite to that of the current. Here we have taken a inverse directions here. So, these are the two equations we are getting here for the loop number 1 and loop number 2. So, what you have to do, if you are taking the value of the direction of the current negative, just take all the currents, it means all the product of I and R in the negative direction and the battery will be the positive. But if you are taking the positive direction of a current, take the value of the battery negative because you are going in the negative direction here. So, these are the two equations. On solving these equations, we will get a value of I1 and I2. So, let us solve the equations here. It will be 10 I1, 15 I1, 15 I2 equal to 3. Next one is 20 I2, 50 I2 minus 15 I1 plus 15 I2 equal to 0. These are the equations we are getting here. Now, 10 plus 15 equal to 25 I1 minus 15 I2 equal to 3. 20 plus 50, 70 and 70 plus 15 gives you 85 I2 minus 15 I1 equal to 0. So, these are the two equations I am getting here for solving. Now, how do you solve these equations here? We will simply solve this equation by equating coefficients here. So, let us equate the coefficients here. equations we have 25I1, 15I2 equal to 3, 15I1 plus 85I2 equal to 0. Now, if I have to equate the coefficient, what I will do, I will take the common factor for 25 and 15. So, common factor for 25 and 15, that is the common multiple that is occurring in both the tables, is 75. So, what I have to do, I am just multiplying this whole equation with 3 and again this whole equation with 3. So, if you are going to multiply both these equations, you will get here 75I1 minus 45I2 equal to 9, and similarly 75I1 plus 255I2 equal to 0. So, you can see that here you are getting 75 and 75, one is having a positive sign and one is having a negative sign. So, just add these equations. So, this is our equation number 3, this is equation number 4. So, we are adding 3 and 4. So, on adding 3 and 4, what you will get here? You will get here 0 plus 0, 1, 2, I2 equal to 9. So, this is the equation I am getting here. So, finally, I will get the value of I2, that is equal to 9 upon 210. So, this is the value of current we have, and on substituting this value in equation number 1, we will get the value of I1 in a similar manner. So, this is how the Kirchoff's law has been applied to both the loops. So, the Kirchoff's second law is very important for solving such kind of the numericals, for determining the value of current in both the circuit. So, this is all about the Kirchoff's law and the advantages of AC over DC we have discussed here. This lecture is over for today. We will deal with many more problems in our next lecture. Thank you so much and have a nice day.